I'm Dr. Harry Cliff. I'm a particle physicist at the University of Cambridge, and I'm also a populariser of science and science writer. Welcome to my exp. Looking at the history of particle physics is quite a nice way to understand the basic building blocks of our universe and what we currently know. So the story really starts over 100 years ago, back in 1897, at the Cavendish Laboratory in Cambridge, which is where I am based now. And that year, a scientist called Joseph John Thomson discovered what we now know is the first elementary particle in the universe, the electron. So he did this experiment with really basic equipment, a glass tube, which was pumped out, all the air is removed, and then you passed an electric current through the tube. And by manipulating these beams of particles that flowed through the tube, Thomson was able to figure out that what was actually flowing through the tube were these particles much lighter than the lightest known atom at the time. And that's what we now know of as the electron. So this is the first elementary particle, a tiny negatively charged particle. And 1897 is really the beginning then of a sort of journey of exploration as other scientists started to gradually unpick and dismantle the atom over the next 20, 30, 40 years or so. I guess that the next major big breakthrough comes about 10, 15 years later in around sort of 1910, 1911, when another scientist called Ernest Rutherford, working at the University of Manchester, and Rutherford had actually been one of Thomson's PhD students back in the late 1890s. He does this very famous experiment with two of his researchers, Geiger and Marsden, where they fire particles called alpha particles, which is a type of radiation emitted by certain radioactive elements. And they fire this at this thin foil of gold. And they discover something very strange, which is that these alpha particles are kind of like really high velocity bullets. So they're kind of, you imagine them like they're like sort of shells from a cannon almost being fired at these atoms of gold. And Rutherford was really surprised to discover that these alpha particles were actually getting knocked backwards off the gold foil occasionally. And this led him to realize eventually that the structure of the atom is the one we now know in school, which is that you have a tiny nucleus, this tiny, extremely dense center of the atom, which is positively charged, which contains almost all the mass of the atom, and the electrons go around the outside. So what was happening in this experiment was these alpha particles were occasionally coming really close to this tiny nucleus, and when they got really close, this enormous positive charge repelled them backwards, in essence. In particle physics, we have this extremely successful and powerful theory known as the Standard Model, which is a really boring name for probably the most impressive intellectual achievement of human beings. So this is a highly mathematical description of how all those different particles interact with each other. And it's written in a language or a sort of framework known as quantum field theory, which is an amalgam of two of the biggest revolutionary ideas in physics of the 20th century, which are relativity, Einstein's theory of relativity, which describes how objects behave when they're traveling very close to the speed of light. Well, actually, not just at the speed of light, but at any speed. But in particular, that's where you get strange behaviors occurring. And also the other idea, which is quantum mechanics, which Einstein also had a role in formulating, which is the language used to describe how the elementary particles behave. And the laws of quantum mechanics are famously really counterintuitive. You know, they basically tell us that the universe isn't deterministic, that you can't know exactly how a particle or how a system will behave. You can only know the probability that it will behave in a certain way. But when you bring these two very powerful ideas together, you eventually arrive at something called quantum field theory, which describes how all these particles interact and behave. Probably the most sort of beautiful idea in quantum field theory is actually what it tells us is that these particles, electrons, quarks, and so on, the way I've described them to you so far, you might kind of be picturing them as little spheres, little marbles perhaps. But actually what quantum field theory says is something quite strange, which is that particles are not actually the fundamental building blocks of the universe. The fundamental building blocks of the universe are actually much less tangible object called fields. So a field is sort of some kind of it's sort of almost like a fluid-like substance that fills all of space. And we've all encountered fields. If you've ever held a magnet next to a piece of metal and you feel a force on that piece of metal at a distance, that's due to something called a magnetic field. Well, what quantum field theory says is that every particle, the photon, the quarks, the electron, have an associated quantum field. And each particle is basically a little ripple moving through an associated quantum field. So an electron is a little ripple in something called the electron field. The photon is a ripple in the photon field, or also known as the electromagnetic field, and so on. So actually, the material universe and everything that exists is actually made out of these fields, and the particles are sort of manifestations of those underlying fields, which is really quite strange, but I think really beautiful idea.